So in this video we are going to fix that small problem that we had when we entered a binary string and the program went into, well, it didn't do anything, but I do know that it's gone into an infinite loop because we are not setting a variable to stop the loop. We need to set variables inside the loop, change them inside the loop to quit the loop. Okay, so we have valid, that was set to true. What we need to do, somewhere inside this loop, set it to false. End of string, that was false but made true with the not. And we did change end of string inside the loop. The only one that we didn't do was valid. And if we handle that, we will manage our program. So let's think about what was happening. So if the binary, if the string at any position was a 1 or a 0, it was fine. And we kept going until we reached the end of the string. So I could enter a binary string and it would be incredibly happy. It would just keep looking at the next one, next one, next one, next one, until reached the end of the string, dropped out of the loop, and it would print valid. What we need it to do is change this if it's invalid. In other words, if it meets a letter or a character or a symbol, we need it to stop. And that is just simply an else statement in my condition here. So if it's a 1 or if it's a 0, do this bit. Otherwise, if we meet a character or a symbol, do this bit. And all we need to do is set valid equal to false. It's as simple as that. Just 2 lines of code to finish that one off. And I believe now when we run our program, that will have cured our problem. So let me save that and run it. So let's just make sure it's got .py on the end. I don't want to end up with a mistake. Yep. So F5. Here we go. Enter a binary string. So let's put a proper one in. 1010. True. It's a binary string. Let's run the program again. Enter a binary string. Let's do the 101A. So we've got the letter at the end. And there we go, false. It's not a binary string. So it went all the way along the string before it found the mistake. Let's see if it will do it to begin with. A1010. There we go. It does it at the start. If you remember, spaces are also characters, so I'm going to put a couple of spaces in, 2 spaces, and then a binary string. What do you think is going to happen? Let's see. I think it should be false because spaces are not 1s or 0s. And there we go. The last thing to check, which we should already know, is if I don't put anything at all, it says you didn't enter anything. So now we have, well, we had before with the for loop, we had a way of just entering a binary string at the keyboard. It's been a little bit complex, difficult. We've had a lot to do. But we've got 2 versions. We've got a for loop version, which was rather straightforward. Let's go and see if I can open that one. Recent files, minitask3. There we go. We had a for loop, which, if you notice, was really short. Okay, so we got some great programming going on there. Not a lot of code involved, but it did the job. And then we used a while loop to do exactly the same job, but we had a lot more coding to do and a lot more thinking to do to solve the problem. In particular, we had to set things before we ever went into the loop. We had to set these things up before we went into the loop to test them and to get them set up. So we needed string length and we needed position to have values before we came into the loop, and we had 2 booleans that we needed to change inside the loop. So the coding was a little harder with a while loop than it was with a for loop. However, this one is more efficient. If I had a string with 1,000 characters and the first one was an invalid character, an A or something, it would quit straight away, whereas this one would go on for the entire 1,000 characters. In programming terms, that is more efficient. In your project, you will be asked to code efficiently, so it would be a good idea to learn how to write for loops and while loops to do the same job, and then test how efficient they are. And we will look at that sometime later in the course on programming efficiency. You will probably submit both pieces of code to the exam board to show that you've looked at efficiency in programming. Anyway, at the moment, both of these do the job that we want. I'm going to use one of them to complete the tasks. So at the moment, that is pretty much the end of task 3. If you didn't understand it, please don't worry. There's a lot of coding in here which we need to cover and practice. Okay, remember, we're still trying to run before we can walk. So I'm showing you how to put things together, giving the thoughts to help you put them together, but by no stretch of the imagination do I expect you to look and just come up with a program like this. You might get somewhere close, particularly with the hints, but I don't expect you to get them first off. That's going to be sometime next year that you'll be able to do this. But we'll do lots of practice to get us there, and I will bring it back to just very simple exercises with raw input and printing and things like that to help you out. So let's move on.